10.8, we're looking at the I variable. And with the I variable, here's the one big thing that they're doing that's different from all the other stuff that we've been doing. And they wait till the very last section to kind of throw a curveball at you. Up until now, we had the square root of negative 25. We said the answer was going to be no solution. And when we get to section 8, well, now they say, well, it's not going to be a real solution, but we're going to get an imaginary solution, or sometimes they call it a complex solution. And basically is this. You're going to replace, so that's everything we've done up until now. Now you're going to replace the negative with I squared. That with the imaginary variable and the complex numbers that they do, the whole big thing they look at is they're going to say that I squared negative 1. Now, and technically for this one, what we're going to do is if we have the square root of 25, that technically we're going to take this negative that we have here and rewrite it as negative 1 times 25, but is the two separate parts here. And now that you have the negative 1 times 25, you're going to take this negative 1 out and replace it with I squared. And just like with everything else that we do, we always put the variable first. Sorry, you put the number first and the variable second. So the only thing you have to do for this one is really you can just kind of rearrange the order. So put the 25 first and let's put the I squared second. And then from there you're just going to square root them. The square root of 25 is 5. The square root of I squared is I. And that's the answer. So here's the big thing. When you're doing all the square roots in section 8, if you start with square root of a negative number, that just means you have to have I in the answer. Everything else, though, you're going to do it just like we were doing before, simplifying the square roots. Anything else that we were going to do here, solving square roots, which we're not going to do with this part of it, but all the simplifying, you're going to treat I just like it was any other variable and just work everything else to be what it's going to be. So if you had to do square root of negative 64, well, as long as you know that square root of 64 is 8, then all you have to do is, if you do square root of negative 64, is just put an I in the answer. And that's it. That's all that's doing is telling you that if you put an I in the answer, that means we started with a negative number inside the square root. Okay. Now, they're still going to make you have different numbers that they're going to ask you to simplify, so that when you're going through this one, you may have to do the square root of negative 40, where it's not a perfect square root number. So what you would do is go ahead and take the 40 and break it down. Some way or another, just to keep breaking this thing down. If you go with the factor tree, it's 2 times 20, which would be 2 times 10, which would be 2 times 5. And with the negative, if you were breaking this thing down, you could basically just put the negative 1 out front. And then you've got 2 times 2 times 2 times 5. Right, and same thing with these. You're going to take the answer that you have that's here. You've got a pair of 2's, so you can put that 2 on the outside. You're left with a 2 times 5 on the inside. So we're going to make that 10. And where you have the negative, you're going to take that part of it and then just put an I at the end of the equation. And depending on where they do this and how sometimes they want the answer with the I at the end of it. Sometimes they'll let you put the I in front. So you have like 2I times the square root of 10. Or you can put this square root of 10 with the 2 first and put the I at the end of it. So hopefully either one of those two answers should be okay. The main thing is when you do this one, that the I is not inside the square root. The only thing that's left inside the square root is number-wise whatever else you could break off this thing. So if you were doing square root of 40, that would have been 2 square root of 10. And again, the only difference is when you go from negative 40 to positive 40 is you just have to put an I in the answer. So let you know it's imaginary. Okay. And on this part, they're going to have you back up to some of the multiplication and division like you were doing earlier back in the chapter with the radicals. And all the examples, on those first few examples we looked at, the directions will basically be just to simplify. And what they'll do after that is they're going to have you, other than just simplifying the number, is now they'll give you 2 that you're working with. So you've got the square root of 81 divided by the square root of 3. And the very first thing you have to do for these is make sure that you always replace the negative inside the square root with the I variable first. That anytime you're doing these, that should be, no matter what you do, whether it's addition or subtraction or multiplication or division, anything you do, if you have a negative number inside the square root, that's the very first thing you have to do before you do anything else, is get rid of the negative part of it first, and then you can go back and break it out and do whatever you want to do with the rest of it. Sometimes it makes a difference in the answer. Sometimes, depending on the problem and how it works out, you'll get the same answer. But there are times where if you don't do this first, you'll get an answer and it will be off by, usually it's off by just the sign of it. That you'll have a negative when you need to have a positive, or you'll have a positive when you need to have a negative. So for these, what we're going to look at is this is basically the square root of 81, and because of the negative, you can go ahead and put the I behind it. Same thing with the 3 on the bottom. It's square root of 3, take the negative out, just put an I in the answer. So anytime you have a negative square root, that technically we're taking out the negative and replacing it with I squared. But again, when you do that, when you square root the I squared, that'll just get you the I variable that's here. So you can always kind of skip this step in the middle in red to know that if you go from here to here, just take the negative out and put an I term on the outside. Okay, from there, now you go ahead and work it out what you can do. Square root of 81, and you can do this one a couple of different ways. Because you have 81 over 3. I know square root of 81 is a perfect square term. So if you wanted to make that a 9, you could, but that leaves you with 9 over square root of 3. Then you have to rationalize, which most of the time people would rather not do that. So what you can do then is, since you've got 81 over 3, go ahead and divide those two numbers and make it square root of 27. The two I terms knock each other out, so they're just gone. So it's really just square root of 27 we're going to simplify. 27 is 9 times 3. Square root of 9 is 3. You'll be left with the radical 3 that's there. And somebody may be saying, well, if we divided a negative by negative, wouldn't we have gotten a positive anyway? In that case, yes. And that's why sometimes it's 50-50. Sometimes it doesn't make a difference in your answer. Sometimes it does. And it depends on the setup and how you go through those. I'll show you one where it does make a difference. Okay, so let's do square root of 7 times the square root of negative 14. All right, and again, before we do anything else, take out the negative and put that as an I term on the outside. Okay, so now you've got 7 times 14, and you can, and because the I is outside, it's kind of taking care of itself now. So now you're going to put these two together. I do 7 times 14. And again, you can multiply it together and make it 98, but you're just going to have to take it and break it back down anyway. So take the 7 and 14 and start breaking it down. Because 14 would be another 2 times 7. So if you break this thing down as much as you possibly can, you've got 7 times 2 times, or 2 times 7 times 7, with the I trailing off the end of it. So you do have the pair of 7s. So you can take that 7 out. Square root of 2 is left on the inside, and then the I term would be hanging out behind the end of it. And again, they may want the I right behind the 7. They should let you go either way. It's almost one of those weird things where I think in Math 100 they almost go with this part, but then when you get to some other cases, sometimes they go with this one. Either one of those two should be okay, though. If they were to count it wrong, that's one of those questions where you could just go back and let me know, and I'd go back and check it just to make sure. All right, with addition and subtraction. Let's go to the next page here. This one's actually a little bit better because for this part, they don't give you anything with square roots. They actually just go ahead and give you the I term in here. So we've got 2 plus 3I, and then plus 1 minus 4I. And for addition and subtraction, you don't do anything different with the I term, because all you're going to do with addition and subtraction is you're just going to be combining like terms. That the any different than X or Y or T or Z or anything else, because the only time you ever have to worry about making any changes is if you have I squared. If you have just I, it's just normally what it is. So you're going to have plus for the whole number part, or for the real number part, and then you'll do 3I minus 4I for the imaginary part. So 2 plus 1 is 3. 3I minus 4I would be a negative I. I mean, you can put negative 1I, but in that case you don't have to have the 1 because it's I. So for the final answer on this one, you would just want 3 minus I. Now, here's the one time where they're going to have you, this is the part where they're going to tell you that you need to write your answers in standard form. And standard form for complex numbers when you have the imaginary part is going to be A plus BI, where you always put the real number part of it first. The I term will always go at the end. So that's one of those where they would make you, if your answer had been negative 1I plus 3, they would make you rearrange it and put the 3 first and then put the negative 1I at the end of it. All right, now the only thing you have to be, and it's not really a big issue, just one thing to kind of be careful of. Addition, usually it's not a problem because you just combine the like terms and go. If you have one that's subtraction, let's say you have 5 minus 6i and then minus 4 minus 8i. Here's the one thing you have to do, and this, again, it's not a big deal, but just be careful. Because you have 5 minus 6i. And most everybody will put minus 4. The one part where you have to be careful of is that some people, it's easy to forget that it's minus a negative 8i, which means that part's going to be a plus 8i. And that part will kind of sneak, especially if you're in a hurry, not really paying attention, that one little sign will sneak up and get you. So just be careful when you're working through that part with subtraction, because subtraction, the minus sign in front means you have to change both of the signs. That, you know, technically it's negative 1 times 4, and it's negative 1 times negative 8. So that's the only thing you have to kind of be careful of when you're going through those. Other than that, everything else, you just work it out just like it normally would be. So then you have 5 minus 4. And then you have negative 6 plus 8 with the I terms. 5 minus 4 is 1. Negative 6 plus 8 would be a positive 2i. Okay, and again, addition, not that big a deal because there's nothing you have to worry about. Subtraction, it's not really anything that's hard. Just be careful with that second sign behind the subtraction part, because that's one it's easy just to forget about it. Okay, so we've got addition and subtraction, so we've got to go ahead and do multiplication and division next. And with the multiplying part, probably going to be doing the full method on all these. Might sneak in a distributive property, but most everything here you're going to be doing the full method. And when you're going through the multiplication part of it, there's only really one thing you have to remember besides doing the full method. That you remember that you have to replace I squared with negative 1. That 90% of it, it's the full method. You're not doing anything different. You're going through all the steps, going through all the parts of it. The only thing you have to be careful of is that when you do the full method, you're going to be using the I variable, not the X variable. So you will get an I squared, and you have to take the I squared out and replace it with negative 1. So let's go with negative 3 plus I times 2 minus 5I. Okay, so negative 3 times 2 is negative 6. Negative 3 times negative 5 is a plus 15i. I times 2, then I times negative 5, I. So you have a 2i, and then minus 5, I squared. And with the old full method, basically you had one thing to do, that you had to combine the two middle two terms. This one, you've got two things you have to do to start with. You are going to combine the two middle two terms. So you have a negative 6. If you do 15 plus 2, that's a 17i. And with the I squared term, that's where you got to take the I squared out and replace it with a negative 1. So it's really negative 5 times negative 1. So that would be a positive 5. And then one more step. Now you're going to take the negative 6, add that to the 5. So that would come out to be negative 1 plus 17i. So it is still just FOIL method going through it. And again, the only difference is that when you get the what would normally be the x squared term, now it's going to be I squared. You have to replace that I squared with -1, which then means you're going to add the first and the last two terms together. And we've got multiplication in there. And again, we could do more of those, but they're all just the same thing. It's still just the FOIL method every time. With division, it's kind of like we did before when we were doing the radicals part of it, that it's really not division. It's where they would tell you to rationalize it. So even though it's division, we're still not going to be doing division. That for this part of it, you're going to have to multiply by the conjugate of the denominator. So even though it says to divide and simplify, it's really not division. It's still just like when we're doing with the radicals. You're multiplying by the conjugate. Same thing for this one. You're still going to multiply by. So if the problem you had was 4i over 5 minus 6i. And we're going to multiply by the conjugate of 5 minus 6i. So make it 5 plus 6i. Again, the only thing you really want to do is when you do that, make sure that those are in parentheses, because technically they are. Same thing with this one, that technically it's in parentheses. Which means bottom part's going to be doing the FOIL method, the top part's going to be doing distributive property. So on the top, we've got 4i times 5, that's 20i. 4 times 6 for 24. And when you do I times I, that is I squared. And again, we'll go back and take the I squared out, replace it with -1. So really that's 20i, do 24 times -1, that's a -24. And we'll go back and rearrange that in a second, put the -24 first, but we'll get the rest of it going on the bottom part. All right, now the good thing is on the bottom part, when you do the FOIL method on the bottom part, that when you multiply by the conjugate, the O and the I will always knock itself out. So it's really just the first times the first. So we're going to do 5 times 5 to get 25. The O and the I would knock each other out. And then you're going to be left with -6 times +6. So it would be a -36. But again, when you do I times I, that would be I squared. And same thing with the one up here. When you have the I squared, replace it with -1. So really that's going to be 25 plus 36. Okay, top part. Let's go ahead and put it in the standard form first. So we'll put the -24 first. And then the plus 20i behind it. And on the bottom, 25 plus 36 would be 61. And same thing as the ones before, but I think this one, before, did they leave it as one fraction? We were leaving it as one fraction before, right? On some of them. This one, though, they actually want you to break this thing up as two separate fractions and see if you can simplify. So it's -24 over 61, and then plus 20 over 61. Put the I variable behind it, and then see if you can simplify anything. For this particular one, with using 61, nothing simplifies. So from what I'm seeing from Alex, that's the answer. And again, if nothing simplifies, this answer would still be okay to me, because they took that answer back in the first part of chapter 10 when we were doing the radicals. So they kind of contradict themselves, because before they were saying this answer was okay. Well, now they actually want it as two separate answers, because this would be the A and this would be the B term when you're doing it in standard form. So I think that's probably the big push they're doing there. But to me, they should have been doing that back in the earlier parts of the sections as well. Okay, so the multiplication and division is still technically the same thing. We're still doing multiplication on both of those. It's just the division, you're just having to multiply by the conjugate, but you're still basically multiplying there. And then the last thing. And again, almost to the bottom of the page here, so let's just start over on a new one. Because they're going to ask you to simplify powers of I. All right, good review question. I think we talked about this last time. What is anything to the 0 power? There we go. It's 1. Okay. And we did go through the powers and the numbers on that, didn't we? Just the basics. Why say anything to the 0 power is 1? Did we show you that one? Maybe. Don't know. Okay. On a side note, let's kind of go back if I didn't. I was thinking I did, but maybe I didn't. Everybody okay that 2 to the third would be 2 times 2 times 2? To get 8. What if you wanted to go up a power of 2? Without having to multiply all the 2's together? What would you just do? If you want to go to 2 to the fourth, you just take this answer and multiply by 2, right? You get 16. You can go back and do 2 times 2 times 2 times 2 if you want to do that. But once you know the one answer, to move up, you just keep multiplying by whatever the base is. What if you started all the way at the top and then wanted to work your way back down? Instead of multiplying by 2, you would just divide by 2. So if you want to go to the second from 8, you would just divide it by 2 to get 4. If you want to go to the first, we know it's 2. But again, if we want to keep going through that same pattern, you would divide it by 2. If you wanted 2 to the 0 power, same thing, you would divide it by 2. So 2 divided by 2 would make it 1. So that's kind of a thought process of where that anything to the 0 power equals 1 comes from. Because, and this was, I don't know if y'all were this way, but when I first saw the 0 power, I thought, well, that would be 0, right? Because it's a 0 power. But let's just say you had 3 to the 0 power. Let's say it was equal to 0. Thought process that you're moving up a power, multiply by 3, or if you move down a power, you divide by 3. If you move up power by multiplying by 3, what's 0 times 3? 0, right? If you went to 3 squared, you'd multiply by 3 again. That's still 0. So if you let anything to the 0 power be 0 to start with, then everything is zeros. So that's why anything to the 0 power has to have some value, so that's why it's going to be 1. Because of the thought process that, you're just multiplying by 2 to go up, or you're dividing by 2 to come down. So you got to have something to start with there. Okay, out of the first power. Anything to the first power is just itself. So that's I. Just a minute ago, we said that I squared is negative 1, because that was the whole thing that everything was looking at. And I to the third, they kind of break it down and say, all right, well, I to the third would be the same thing as I to the 2 plus 1. And we just said that I squared. So you can basically break it apart as I squared. If you got 2 plus 1, you could say it's I squared plus I to the first. And I squared was negative 1. And I was just I. So if you do negative 1 times I, that would make it negative I. Now, everything after that is going to repeat. That if you did I to the 4th power, that you could kind of say, all right, well, that would be, if you want to do it this way, that would be I to the 3rd, which is negative I times, you can make that I to the 3 plus 1, or you can make it 2 times 2 if you wanted to. There's all kinds of different ways you could take 4 and break it up. So you could do 3 times 1, or 3 plus 1, or you could do 2 times 2. So you can make that I squared times I squared. So if you do that, that's negative 1 times negative 1. And that puts you back at 1. And if you keep going through those, it's that same pattern. So here's kind of what they're wanting you to see for this part. That basically is this: that for everything you're going to do, you only have 4 options for the answers. You're going to have I to the 0 equals 1. You're going to have I to the first equals I, because again, first power of that one. We just said that I squared was negative 1, because that was kind of the whole thing that kicked off section 8. And then for I to the third, that one we said was a negative I. So when we're talking about terms of I, no matter what the powers are, that's going to be one of the 4 answers that we're looking for. So here's how you're going to take some answer and get it to what it's going to be. Let's say you had I to the 19th. Here's what you're going to do. You're going to divide the power by 4. So we're going to take 19th power divided by 4. 4 going to 19 4 times, with 3 left over. And basically is this: the remainder that you have is the power of I that you're going to use for your answer. So for this one, we had a remainder of 3. So we're going to use the answer that's got I to the 3rd power. So for this one, your answer would be, well, if I to the 3rd power, the answer is negative I. So for this one, that's going to be your answer. It's going to be negative I. Actually, let's put that over here. Okay, so any number they give to you, the only 4 options you have for the answer, and again, it's going to be multiple choice. You're going to have 1 I, negative 1, or negative I. That's the 4 choices you have, and they're just going to give you all kinds of random numbers, and they're going to ask you, okay, just tell me what this would be. So somebody give me a number that's kind of big. Don't give me anything small. 70s, 80s, 90s, 120, something like that. I-77. Bingo, right? Maybe, but okay. So for 77, take 77 and divide it by 4. 7 minus 4 is 3. Bring that to 7. 9 times 4 is 36. Remainder is 1. So that is the key thing you're looking for. Your remainder is 1. So that means you're going to use I to the 1st power. And if you go back to that chart, I, the 1st power, was just I. So that would be your answer. All right, let's give you another one. Let's say it's I to the 124. So it's 4 divided into 124. 4 going to 12 3 times. Nothing left over there. 4 going to 4 1 time. Nothing left over there. So for that one, again, remainder was 0, so you're going to use out of the 0 power. But anything to the 0 power is 1, so 1 is your answer. So what you're trying to do, and again, that just make out a little chart. Out of the 0, the first is squared is -1, and then out of the third is the -I. And all you're going to do is you're going to look for the remainder. Whatever the remainder is, that's the power 0 through 3 that you would have, and just use that answer that goes with it. So even if they give you some huge number, get out of the 721st power. You're still going to take 4 and divide it into 721. So 4 going to 32 8 times. Goes evenly, so when you bring down the 1, 4 won't go into 1. So you're going to have 1 left over. Again, because your remainder is 1, you're going to use out of the first power. Again, if it's out of the first power, the answer is just I. So for every single one of those, you're going to use those 4 things, and that's your only 4 answers. And again, the remainder is the answer you would put here for the power of I, and again, just have that part memorized as to which one goes with which.